Hello students, this is Mr. Hali again on chapter 7. This is our fifth installment. This one is chapter 7.5, division property of exponents. As usual, I have you start this with your notes and pencils and papers and everything ready with you. And as usual, you can pause the video anytime you want. Here is the objective for you to copy. Use division properties of exponents to evaluate and simplify expression. Let's start with the first example. First example is going to simplify this one. A to the fifth divided by a squared. Now let's look at the factors of a to the fifth. What are they? Here they are. All right. They're going to be a times a times a times a times a times a times a. Okay. Then a squared would be a times a. Now remember, if you have the same denominators, of course you cancel them out, so the first a is gone, the second a is gone. Now what are we left with? A to the third. All right, here we go. Now here's the answer. Now how about, for example, a simplified way, an easier way to do it? As the rule of division of property of exponents this says, you just subtract from 5, take away 2, and here, voila, here's your answer. And they are identical to both of them, okay? And here's my arrow to show you that they are the same. Now, I want you to copy this for your notes, the bottom one. Please pause the video and copy this one. So if I have a to the m divide a by n, of course I subtract them, and this is called quotient of powers property. Please pause the video and copy this one. To the next video, here we go. For example, simplify. These are the two different ways to do it. The first way is the way I showed you in the first video, first screen, and then the second one we're just going to subtract it. Okay, here we go. 10 m to the fourth means 2 times 5. The factors of 10 is 2 times 5 times m times m times m times m, and 15 is actually the factors of 15 is 3 times 5 and m. So now we cancel out anything in common to the numerator and the denominator, which is going to be 5 and m. And what am I left with? 2m cubed over 3. And that's my final answer. Now, if I would do it differently, of course, I would simplify 10 and 15, which is I divide them both by 5. And my answer would be 2 over 3. And then 4 minus 1, because m, there is no denominator, so you subtract it, and that's your final answer. Let's do number 2 now. Number 2, of course, I can simplify 6 and 8. So when I simplify it, I divide them, both of them, by 2. And then remember, 3 and negative 4 will be subtracted from each other. And what I will have is, I will have 3x cubed times x to the fourth, because I subtracted. And now if I subtract 3 and 4, what do I get? 3x to the seventh over 4. Now be careful. What I'm doing is I'm actually subtracting a negative 4 from 3. When I subtract, the double negative will give me positive, therefore I add them. That's what happened, okay? Now here's a different way to do it. You see what I'm doing? Double negative, and voila, here's your answer. They're the same, okay? Now, two more examples. Here's, for example, another one we can do. What do we do? If it's negative, of course, if it's negative, we are going to put it at as a denominator. The denominator becomes numerator. And then my final answer is going to be this one. Now you do number 2, number 3, and number 4. Pause the video. Okay, let's look at number 2. Number 2, remember the same thing like we did with number 1. 6 has the same base. And then if I go there, because it's so it becomes 6 plus 2, 2 plus 1 would be 3. And that's my final answer. Now let's look at number 3. It all have the same basis. 3 is the base. And then at the beginning I have 4 and negative 6. And then at the bottom I have 1. Look what I'm going to do. It's negative, I bring it down. So 3 to the fourth. And I have 3 to the first times 3 to the sixth. And I combine power to power rules, tells me I combine them 3 to the 4th over 3 to the 7th. There are many ways of doing it, but this is the easier way for me. So 4 minus 7 will give me. Now remember, you cannot leave an exponent as a negative, therefore it will become the reciprocal 1 over 27. Then you do the same thing for number 4. Remember, these two, negative 3 and negative 2, have to be combined, or I can bring it down. Same way. Okay, here's the answer for you. Any questions, of course, you can shoot me an email. Now, let's look at the next screen. On the next screen, we're going to simplify. Now we have x has an exponent, the exponent is 3 and the bottom is 1, and y is a negative 2. Remember, if it's a negative, if it's a numerator, we can make it a denominator, and a denominator becomes a numerator. Okay, so the y has to go up because it's negative. So what do I have now? X to the third times y squared over x. Of course, I'm going to simplify that, and that's my final answer. Let's look at number 2 again. Remember, anything negative goes down or goes up, depending where it is. In this case, negative 1 for n will go down, and then p will go up because they are negative. Now here's the way I write it. Now I do the rule of common basis, and now I simplify it, and this is my final answer. It's a little fast, let me know. Okay, how about this? That looks a little complicated and scary. First of all, don't forget 3 and 12 can be simplified. 3 goes into 12 4 times. And then a is negative, so it goes down. B is negative, goes up. Okay, now here's what I wrote. And 3 and 12 are cancelled. So what am I left with? I do the rule of common basis. 3 plus 4 is 7. And then I have my c. Cancel out because c over c is 1. And this is my final answer. Let's see you guys do number 4 on your own now. And you can pause the video for a second. Okay. Now remember, the negatives have to go up and down depending on what we have. And look at it very carefully. It's very simple. I did a little differently, but it's the same thing. Okay. And here's your final answer. Now, this is a new section, power of quotient property. Now, if I have a division, if I'm dividing x by y, the a will be distributed to both x and y. Remember, to both of them. That's what the power of quotient property says. Okay. So let's do the example number 1, and then you can do number 2 on your own. Now the 2 will be distributed to both 3 and x and then 5. Okay, so 3 squared, x squared, 5 squared. That's what I'm getting. So 3 squared is 9, x squared is 2, and then over 25, and that's my final answer. Now number 2, you do it on your own. I'll give you time to do it. Pause the video and then check with me in seconds. Okay, remember, 7 will be distributed, 2 will be distributed to 7, to a negative 2, b to the 4th, and then 3, 1. Okay, that's what we are doing. So remember, 7 squared is going to be 49. And the a was negative, we dropped it down. Look at it carefully. It's nothing really scary. Now, when I distribute the properties, 7 becomes 49, b becomes to the 8th. And 3 times 3 is 9, and then a squared times 4 is 4. Okay, here we go. Now, here's another example we can do on our own. Number 1, you can do it, and then pause the video, please. Okay, remember, the exponent is negative, therefore everything gets reversed. It will be inversed. Okay? You see that? I hope you're understanding it. Now the 2 will be distributed. And this is the final answer. Look at it carefully. Now let's look at number 2 now. Number 2, remember, anything negative gets reversed. If it's on the numerator, it becomes the denominator. Denominator becomes numerator. Okay. Let's look at the first part. See what I did? X was negative, it goes down. Y was negative, goes up. All right. Now, rule of common base tells me I can add them. So 5y cubed and y squared becomes 5y to the 5th and x squared. And then the other one will be 3x. There was a 1 that he didn't write. And then 3 plus 1 is 4. And y to the 4 is over 10. Now I can cancel out the 5 and the 10. All right. And then I can also cancel out the x squared, the x to the 4th. And that's my final answer now. I hope you got it. Now here's a word problem we're going to do. Okay, the Colorado Department of Education spent about 4.408 times 10 to the 9th dollars in fiscal year 2004-2005 on the public schools. There were about 7.6 times 10 to the 5th students enrolled in public schools. What was the average spending per student? Write your answer in standard form. So what we are going to do is we actually going to divide the amount of money that they spent and by the number of students. Okay, and here we go. So the total spending divided by total number of students. The red is the number of money and the amount of money, and the bottom is the number of students. Now when we divide, remember the left side gets divided separately and the right side gets divided separately. Okay, and when we look at it now, look what happens now. From 10 to the 9th, I'm going to subtract 10 to the 5th, and then you can use a calculator if you want to divide 4.408 divided by 7.6. Next slide. Here we go. So when I divide that number, I get 0.58. Now remember, 10 to the 9 minus 5 is going to be 4, but that's not written in standard format. Of course, for me to write it in the right format, I need to move the 8. So this is the final answer. It means 0.58 times 10 to the 4th would be $5,800 per student, and that has changed a lot now. At least in our district. Now okay, here's the one that you can do on your own. Please pause the video. Thank you, and here's your answer. When you simplify it, that's what you get. 12,800.